All right, guys, here we go. These are logs and log properties. I tried to put a lot of thought into this and see, if you're weak in logs, I think this will really, really help, especially in understanding where the properties come from. Let's try not to be robots. Yes, it's okay to just memorize properties and I'm just going to use these properties. But if someone ever asks, like, well, where do they come from? Like, I don't know. I just use it because that's what I found on the internet. I found these properties and they work. So blah blah blah. So let's talk about logs. Logs are inverses of exponentials, and you're going to see why right now. And I start here with, let's do the basics. Any positive number can be written as a power of 10. Why did I choose 10? Because if you write log by itself, it's a power of 10. Really, any positive number can be written as a power of any number, not any positive number. Because we got to, 1 can't be, because 1 to any power is still 1. So any positive number besides 1. And then I give you an example. 3 equals 10 to the power 0.477. That came from somewhere. 5 equals 10 to the power 0.6989. 15 equals 10 to the power 1.1760. So where did all these numbers come from? Well, if I type in log 3 here, you'll notice that I get 0.477. So that's what I'm doing right here, guys. It says the exponents 0.477, 0.6989, 1.170 are called the base 10 logarithms. And it's called the base 10 logarithms of 3, 5, and 15 because log 3 is 0.4771. So we're already getting our first property here. So log written by itself has a base of 10. So what does that mean? That means 10 to the power 0.4771, and then those 3 dots mean that it goes forever, equals 3. So from that we get 10 to the power 0.6989 equals 5, and 10 to the power 1.1760 equals 15. Now there's a reason why I chose these numbers in particular. 3 times 5 is 15, guys. And you're going to see that it's going to work out just beautifully, these properties, in a little bit. So I don't want to, so there it is, log 3 is 0.477, and I want to show you log 5 real quick. And there it is, 0.69897, and so on and so forth. Let's just continue, guys. So here we go. So we start first with the product, and I didn't write any more after that, but I might just do another one. Maybe I'll do all 3, product quotient power. All right, so 15 equals 3 times 5. Well, I know that 3 is equal to 10 to the power 0.4771. So I'm going to rewrite this, and then we'll 10 to the power 0.4771. And then I know that 5 is nothing more than 10 to the power 0.6989. So 10 to the power 0.6989. Now, when you guys were in Algebra 1, or maybe Algebra 2 as well, but Algebra 1 specifically, when you did laws of exponents, so here's your side note, your algebra teacher told you if you have x squared times x cubed, because your bases are the same, that this is equivalent to x to the 5th power. And how did you get that 5th power? Well, that 5th power, you got it from 2 plus 3. So that's exactly what I'm doing here, guys. My bases are the same. So that means I can just add up these exponents here. And I'm going to write 10 to the power 0.4771 plus 0.6989. I hope you guys followed along there. So that is a true statement. If I were to go to my calculator and I were to go 10 to the power, and I'm going to scroll up, and I'm going to push enter on that 0.477 plus, well, I guess I got to push enter first, huh? Plus, and then I go to the 0.69 and I push enter again. Oh, yeah, I did it right. And then I push enter. OMG, I get 15. Yay, awesome. Okay, there it is. No big deal. Was that simple? Okay, great. I hope that you guys were saying yes and not a no. All right. So where do the properties of the logs come from? Now, don't worry. I know that I haven't done the quotient or the power one. I just wanted to go to this one real quick. So I have here log 15 equals log 3 times log 5. And then I'm going to say, well, it says here, let's see. For this example, we can infer that logarithms have the same properties as exponents. Okay. Since logarithms are exponents, oh, okay, wow. So they're telling me that logarithms are exponents. I can rewrite this as log 3 plus log 5. Now, hold on, relax. I know a lot of you guys are already screaming. Okay, what's going on? What's going on, Chavez? Okay, do you guys agree that log 3 is 0.4771? I'm hoping that you guys are saying yes. Real quick, check it out. I'm going to push log 3, and there it is. Log 3, 0.4771. We did that earlier. And then log 5 is equal to 0.6989. Yes, check, check. Well, then that means this plus here is that plus. See? So, Chavez, what does this all mean? It means that if I were to go 10 to the power log 3 plus log 5, because these are just like exponents, so that's log 3, that's log 5. So that's going to give me 15 as well. It better give me 15, if not I'm lying. So let's see. 10 to the power log 3. Oh man, come on, buddy. Log 3 plus log 5. And I'm going to push enter. And then, oh my God, 15. Yes. So hopefully you can see logs are just like exponents, guys. They're just like exponents. The properties for the properties for logs follow the properties of exponents. So if I have something like, I don't know, let's go ahead and just talk about, like, if I have 15 divided by which one do I have? I have the 3, so I'm going to go 15 divided by 3. Well, the 15 is the same thing as saying 10 to the power 1.1760 divided by 10 to the power 0.4771. So that's going to give you 10 to the power. Well, when you're dividing, here's another side note, and I'm sorry that I'm writing it the same color. X to the 5th over x squared, when you had algebra 1, you did 5 minus 2. So you said that was x to the 3rd power. That's what I'm doing here, right here. 1.1760 minus 0.4771. The magic number, when I subtract that, better be, well, 15 divided by 3 is 5, right? So that better be 10 to the power 0.6989. So let's see. Let's see if that's true, guys. I'm going to write log 15, because I don't have that number here yet. So I'm going to write 10 to the power of this guy. And then I'm going to divide by 10 to the power of the, what was it, the 3? So I got to scroll up a pretty significant amount there. Oh, there it is. My bad. Enter. And when I push enter, I get 5. OMG, you're supposed to get 5. Let's see, real quick. I just want to show you the 1.17 minus the 0.4771. So 1.17 minus the 0.4771. Come on, buddy. Enter. And when I subtract those, I get the 0.6989, and that is, so if I go 10 to the power of that, 10 to the power of my answer. Check it out, guys. Wow, 5. Everything works out perfectly. So I hope that makes sense. Now we just got one more rule. So here, I guess I should have written that way down here. So I got one more rule. Let's say I have something like log and 3 to the power 3. Oh, I don't want to use the same number again. Log 3 to the power 4. All right, well, that means log 3 plus log, oh, okay, I don't want to take any shortcuts. Log 3 times 3 times 3 times 3. And we just covered what the product property was for logs. It's just like exponentials. And I can rewrite this log 3 times 3 times 3 times 3 times 3 as log 3 plus log 3 plus log 3 plus log 3. When I do that, 1, 2, 3, 4, you have 4 of them, guys. So this is equivalent to 4 log 3. So you can see here, there's some patterns. I can just rewrite that and move that up there. See? So hopefully that made sense to you. You saw the quotient one right there, right here. So log of 15 over 3, just from this one right here, is equivalent to log 15 minus log 3. Where that minus is like your division sign, right? Your quotient sign. That minus here is that guy. All right. I'm hoping all this is making sense. So here we go. And I wrote properties and I didn't write the properties. So I guess the first one we noticed right off the bat is how this is the first property that we noticed. Exponential type deal. So I guess let's just use your ABC letters. So I'm going to say log base B, and I chose the B letter here because, it's the first base, starts with the letter B here, of A equals C. The first property we said was that this is equivalent to B, base B, to the power C equals A. That's what we said right here, guys. Right here. So this is how you turn a log into exponential or exponential into log. Log to exponential or exponential into log. So if you go to the right side, you turn it into an exponential. If you go to the left side from exponential to log, see, pretty simple, guys. I don't think that's too extreme. I think that's pretty basic. And then the next rule we said, let's see, what did we say? Product rule, right? So log any base of A times C is going to be equal to log that base of A plus log that base of C. If you don't see a base, if you don't see the word letter B, it's log base 10. And then we talked about quotient. So log, this is called a product because it's obvious it's a product. So now let's talk quotient. Quotient. So log any base of A over C, as long as C is not 0, is log that same base of A minus log that same base of C. And then we have the power rule, which we identified right here. And then we said, let's see, log base B of A to the power C is nothing more than C log base B of A. So there it is, guys. I guess one more. Let's see. Yeah, one more. Well, we're going to be talking about it when they do change of base. But log base E of X is equal to natural log of X. But we'll talk about this when we get there. Right now, we're not there yet. So let's not even talk about it. Oh, man. I just noticed that I used X and Y over here. So maybe I should have used X and Y over there. No big deal. Algebraically, logarithms of any base, log base B of X equals Y. If and only if B to the power Y equals X. There's your if and only if statements here, where B is a positive number and B cannot equal to 1, because if you think about it, if, like we said earlier, 1 to any power is still 1, right? So yeah. Where X is always greater than 0, verbally, log base B of X equals Y means that Y is the exponent of B. That gives X as the answer. Yeah, B to the power of Y equals X. See? So yeah, so here we go. Write log base 5 of C equals A as an exponential form. So that means they want to see a power. So in exponential form, here we go. I'm just using my properties, and I'm using the top one here. If I want to put a number on it, I'm going to say number 1, number 2, number 3, number 4. So I'm just using number 1. So I'm going to write 5 to the power of A equals C. And there it is. You're done. That's all they want, guys. All right, here we go. Write Z to the power of 4 equals M in logarithm form. Okay, so let's see. The base is Z here, so I'm going to write log base Z. And then since I equal M, then that means that the M must come in the inside of, this must be the argument of your log, equals 4. And there it is, guys. And if we check it, let's see. Z to the power 4. So Z to the power 4 equals the inside of that argument. Boom, it works. Just property 1. Cool? All right, awesome. All right, guys. Now we're just using the properties, and we've talked about all properties. Hopefully, I hope that they were clear. If they weren't, please leave a comment, and I will try to redo them again. So here we go. Condense the following logarithms into a single logarithm in simplest form. So I have a plus there, guys. So that means log, and then I have the base. The bases are the same. So the first thing I'm going to do, I'm going to move that Z right here where the C is. I should have used a different letter than Z and C because they both sound the same, right? Log base B plus log of c to the z power. And I probably should have done a better job and used parentheses like so. And now if I want 1, so here we go. I'm going to combine them. The logs are the same, so I'm going to write log, open parenthesis, b to the c, b times c to the z power. Close it. And there it is. Single log. All right. Again on this one, guys. So I have 4 log w minus log x. So the first thing I'm going to do is I'm going to move the 4 to be a power for w. So log of w to the 4th power minus log of x. And my apologies, I should have put parentheses here, guys. No big deal. So now from there, bases are the same. And I can conclude that this is going to be nothing more than log of w to the 4th over x. And there it is, guys. All right, here we go. Letter C. First thing I do, log base b of 3 squared plus log base b of 9. Well, log base b of 3 squared, that's just 9. So log of 9 plus log of 9. Nope, the b didn't go anywhere, guys. Sorry. And then log base b of 9 times log base b of 9. That's just going to be log base b of 81 because I just did 9 times 9. All right, let's keep going. Same thing here. So let's see. I'm going to move the 3 to be a power for that too, guys. Log base b of 2 to the 3rd power minus log base b of 4. The bases are the same. 2 to the 3rd is 2 times 2 is 4. 4 times 2 is 8. So that's 8. So log base b of 8 minus log base b of 4. So then that means I have log base b of 8 over 4. So finally, that is log base b of 2. And no, you didn't have to do all that, guys. I'm just trying to show you guys. All right, here we go. Now they want me to expand. So let's expand. And they want to see just log x, log y, and log z, if there's a z in there. So this is just going to be log of x squared plus log of y to the 5th. And then I'm going to move this 2 on the outside, and I'm going to move that 5 to the outside. So I have 2 log x plus 5 log y. Yay. All right, on this one here, we're going to do the same thing, guys. It's a quotient. I probably should have, my bad habits are coming out. I probably should have done that. I'm going to put it in blue so we don't confuse with what I have here on the top. So log of x to the 5th minus log of y squared. I'm going to bring these exponents or these powers to the front, guys. So I'm going to have 5 log x minus 2 log y. And there it is. That's it. All right. This one here, first thing I'm going to do is I'm going to write this as log x squared over z times y to the half. Why did I do that? I have a square root on it, guys. So square root in terms of a power means half. So now I'm ready. Now I'm going to write log of x squared minus giant bracket or giant parenthesis, whatever you think is easier for you, log of z plus log of y to the half. I'm going to move the half to the front, and I'm going to distribute the negative. So here's what I finally have. So I have, and I'm going to move this 2 to the front as well. 2 log x minus, let's see, log z minus, bring the half to the front, 1/2 log y. And there it is, guys. Yay. See, it's not so bad. It's not so bad at all. All right, it says, write the log equation in an exponential equation. Do not solve for x. Let us just perfect converting log equation to exponentials. Okay, I have no base here. Well, it's not written, so that means it's base 10. So I'm going to write, you can put the 10 there if you want. So 10 to the power 3 equals 5x minus 2, and that's it. They don't want me to solve for x. Leave it alone. All right, here we go. For this one here, I have the 2x as my base. So I'm going to write 2x. Oh, the x is not a power. 2x to the power 3 equals 5x. All right. All right. Ln. We said that earlier that log base e of x equals ln of x. And I know that I didn't think I was going to put that in there. I had forgotten that I had typed it in. Maybe I should have written it for the next assignment. But since it's already here, convert ln x, guys. So we're going to use side note, and I'm going to say log base e of x equals ln x. Then we're going to just say, we're going to convert this. So substitution, log base e of x equals 1/2. So that means e raised to the power 1/2 equals x. If you want to be fancy, you can say that the square root of e is equal to x. But this is more than enough right here for what they want on the problem here. So finally, letter D here, 4 to the third power equals 2x plus 7, and you're done. All right, so now let's see, solve for the positive value of x. So now we're about to have some fun. All right, if you have something like this one, so let's see, x to the power 6 equals 729. If you know what this is, it's a perfect, this one is a perfect value for x. So you can take the 6 root, and that will give you your x value, and it's going to be 3. So if I come over here and I write 729 to the 6th root, so I can either go to the 1/6 power here, and there it is, 3. Or you could always do this, guys, math, and then this number 5, and then you can put 729 inside of that, 729, and on the outside of that, instead of where it says answer, put the number 6 in there, and 6 root, there it is, 3. So if you did not recognize that, we'd have to do something else, guys. Worst case scenario, if you have, let's say you don't recognize it. So let's say you're like x to the 6 equals 729, and you do not recognize it at all. You can use the y equals feature, guys, and you can just go, okay, and my y equals, I'm going to write x to the power 6. So this is a power function. And then I'm just going to go to my table, and oh, lo and behold, there it is at 3. It equals 729. So if you don't recognize it, that's how you can do it, guys. So here we go on this one, and I did this one on purpose, as you can see. I wasn't very creative, guys, so I just went ahead and just did another one that with the same numbers here. So log base 3 729 equals x. All right, well, 3 to the power x equals 729. And you can imagine, well, this is a perfect one. Yes, you guessed it, that's 6 there. 3 to the power 6 does equal 729. So that means that x must equal 6. And the way you do that, if you come back here and you rewrite this guy as, what did I already forgot my expression. 3 to the power x. So 3 to the power x. And then I push enter. And then again, go to my little table. And if you see there, when x is 6, the y value is 729. So there it is, guys. That's how we can do it. Now look at this one here. This one says log base 5 of 17 equals x. So it's not going to be perfect. So I'm going to write 5 to the power x equals 17. And if you go to your calculator and you're like, okay, well, I mean, I'm not trying to insult your intelligence, guys. I'm just trying to explain here. I know that a lot of you are like going to be like, well, 5 to the power 1 is 5, and 5 to the power 2 is 25. So obviously it's not going to be an integer. So if you go to your calculator and you push an x in there, come on, buddy, and I go to my table, you can see that it doesn't equal 17 at 1 or at 2. So it's obviously not perfect. So with what we know right now, there is something called a change of base, but we're not going to do that. So what I want to do is I want to bring that x down. So what you do is you put an ln, and whatever you do to one side, you got to do to the other side, ln. So now that I have ln of 5 to the power x equals ln of 17, oh, we haven't talked about ln, huh? Okay, let's use logs. Log and log. Log and log. Sorry, guys. So bring that x to the bottom. X equals, I can't just solve, x log 5 equals log 17. So now that I have x here, if I want to get it by itself, I just divide by log 5. And there it is, guys. So my answer, if you don't have a calculator, and by the way, this is a very popular question for like SAT or admissions or admission exam without a calculator. So there it is, log 17 divided by log 5. Whatever that answer is, It's some number. I don't know what that number is, but whatever that answer is, there it is. So let's see if this is true, guys. I'm gonna go ahead and take my little calculator here, and I want to see that this is a true statement. So I'm gonna write alpha y equals, and that's gonna give me my little fraction. And on the top, I'm gonna write log 17, and on the bottom, I'm gonna write log 5, and I'm gonna push enter, and it's gonna give me a number. And there it is, 1.760, blah, blah, blah. So if this is a true statement, I'm going to push. So here we go. Here's what I'm trying to do. I'm trying to write log 5 of 17 to see if it does equal that number. So I push math, and I think it's here pretty quickly, right? Log base. There it is. Letter A, log base. And I'll push a number 5. And I'm going to put 17 inside the argument. And if I push enter, hallelujah. So we got it. Yep, this works. All right. There's also something called change of base, but we'll get there tomorrow, guys, or the next video. All right, here we go. So now they're asking us to solve for x. Remember that you have to have a positive argument, or whatever this expression is. It has to be positive because the domain of logs are just positive values. We'll talk about graphing in the future. When did we get 8 here? Okay, anyways, we'll just do this here right now. So log base 2 of 2x minus 4 log base 2 of 3 equals 1. So what I want to do is I see quotient and I see my same logs. So I'm going to write log base 2. Well, I guess before I combine them, I'm going to convert this power here first. 2x minus log base 2 of 3 to the 4th power equals 1. That's a 2 down there. It just came out looking like a z. All right. Now, let's see. 3 to the 4th power, I believe that's 81. 3 times 3 is 9, and then 9 times 9 is 81. Yeah. So I'm going to write log base 2 of 2x minus log base 2 of 81 equals 1. So I have a minus here, so I'm going to turn this into a quotient for logs. So log of 2x over 81 equals 1. And now I'm going to turn this into an exponent. So 2 to the power 1 equals 2x over 81. So 2 to the power 1 is just 2, guys. And I'm going to multiply by 81 here. Or you can just cancel the 2s. It doesn't matter. Let's go ahead and multiply by 81. So I don't want to confuse anyone. What's that? 80, 160, 162. 162 equals 2x. Divide by 2, and then you're back where you started. So x equals 81. So let's see if this is true. Let's see if x really does equal 81. So let's see. I'm going to go math, and it was in the very bottom, log base 2 of 2 times 81. And then get out of there. Minus 4 log, for math, log base 2 of 3. I'm going to push enter, and it better be 1. And there it is, guys. It works. All right, let's do one more. So again, I have a plus here. Turn that 2 there to put a power after that 5 there. So log base 7 of 5x plus 2 log base 7 of 5 squared equals 0. So 5 squared is 25. Oh, I no longer have that 2. Sorry, guys. Log base 7 of 5 squared. So there we go. I fixed my error. I know some of you were probably screaming there. So log base 7, and I'm going to have 5x times 25 equals 0. Well, 25 times 5, let's see, 25, 50, 75, 100, 125. So log base 7 of 125x equals 0. So now I'm going to turn this into an exponent, guys. So 7 to the 0 power equals 125x. Remember, anything raised to the 0 is always 1. So 1 equals 125x. Divide by 125 both sides. So x equals 1 over 125. Now we're going to see if this is true. So let's see. Bring my calculator out. 1 over 125. All right. So bring my calculator out. I'm going to go math. and I'm going to go to A, and I'm going to write base 7 of 5 times, and in parentheses, I'm going to write 1 divided by 125, close, and I'm going to get out of there. I'm going to write 2, nope, not alpha, math, log base 7, and I'll push 5 on the inside of that, and then get out of there, and then if I push enter, I better get, I just noticed that I didn't put a plus. And guys, how come you guys didn't tell me? Second, nope. I'm kidding, guys. I know I can't hear you guys. Don't hate me. Plus, all right. There we go. Enter. Yay, it worked, guys. All right, so I hope that we are good, guys. I hope we understood that. We have a real quick assignment on your DM. So I think you guys will be okay. All right, later, guys. Bye. Oh, give it a thumbs up if you enjoyed it. All right, later.